Hello and welcome to the appendix to the Idiomatic Kotlin episode on the result mechanism. In this video, I want to showcase to you how you would apply the result mechanism on a real-world-esque code example and what you should look out for. So what I prepared for you right here is a paycheck service, and for now it only has a single public method called generate and persist paychecks. As you can read here in the kdocs, it does the following. Returns an ordered list of paycheck sorted lexicographically by the name of the developer. Additionally, each paycheck, successfully generated or not, is persisted into the database. So you might have noticed that this is related to the examples from earlier videos of myself, including the Idiomatic Kotlin series. So we have here a developer, which has a few fields. The ones we're probably interested in right now is the developer's name, which is simply their given first names as well as a family name. All the other code here you can check out in the GitHub repository attached to this episode and all the previous episodes. But for now, this is not really important. We only need to care about the fields, really. Right. If we go back to the method itself, we can see that the point of this method is that we want to return a paycheck. Let's quickly check what that has. It has the date that it was issued, the period that it covers. For this, I made a custom type local date range, which is simply a closed range from between two local dates. So this would be the paycheck, the period when the developer is paid. A reference to the developer that we're paying, their hourly rate as a big decimal, and how many hours they worked within this period, such that we can calculate how much money we have to pay them, or how much has to be in the paycheck. Right. The idea of this that you could think about is that this would be run in a batch job or something, because as you can tell here, or as it says, successfully generated or not, we persist this information to the database. So if it worked, we want to persist, hey, there's a paycheck now, and if it failed, we also want to persist it, presumably such that we can rerun it at a later point and retrying the ones that failed earlier. So what we have right here as dependencies are a human resource client. All this is or that you have to imagine about this is that it's an interface to some external service where the developer's salaries or the hourly rates, as well as how many hours they worked, are stored. And it has a few methods that we're gonna use in a second that can potentially fail, which is precisely why I want to look into the result mechanism, of course. Then we have the paycheck repository, pretty straightforward, just to persist our paychecks, the developer repository to fetch the developers, and finally a clock from Java, which we need to come up with what today is. And that's precisely where we use it directly. So let's jump right into the code. So we receive here a developer type, which is simply an enum for now with the values front end and back end. So this is the developers that we want to generate the paychecks for. We receive the year and the month, which is then the period, of course. And finally, we want to later return a list of paycheck, but also persisting them, of course. So we simply get what today is, and we come up with the period. This we can, of course, do if we know year and month. We can see, okay, what's the first and last date of the month, which I implemented down here. And then, we have the period of the paycheck. Now let's get to the meat. And this is what we're gonna refactor now, because, as you can see, it's not the prettiest code, but you'll see in a second why it is not the prettiest. So what we want to simply do is get all developers by the type that we received here. So this we would start out here with just a set of developer. And then if you watched the previous episode, you noticed this thing, or maybe you just know it. If not, make sure to watch that if you're interested. So we convert this set into a sequence because we have quite a lot of processing step in our collection pipeline here. So this, in this case, probably makes a lot of sense. As I said, if you want to know why, make sure to check out the previous episode. The first thing we do, of course, is to filter out everything for every developer that we could generate a paycheck in a previous run, because yeah, otherwise we paid them twice, which they probably pretty happy about, but our stakeholders probably not so much. So filter not that it exists, pretty straightforward, I guess. So at this first mapping operation here, we only have developers left. We do not generate a paycheck yet for the period, of course. So if you run this again a month later, it would obviously generate a new one. So what I did right here is that this paycheck that we have right here, it has a builder in itself, such that we can set the fields over time, because obviously in Kotlin, to keep it idiomatic, all the fields are immutable, such that, yeah, we cannot set first the rate and then how many hours they worked, which is precisely what we want to do right now. Of course, in that case, we would have to make it mutable with the var keyword, which, if you can avoid it, you probably want to avoid, which is why this builder makes a lot of sense. So we can have like a partially built paycheck, and then only at the end we call build, which just returns us an immutable one and also checks that all the fields were set in the past. Right. So what we simply do here is that we start with something that can actually not fail, not throw an exception. Well, there's probably some possibility, but not really. Which is that we simply start or create a new builder instance and set already the date, today, the period, as well as the developer. So yeah, we map, so we iterate over all of them, of course. The other thing we do here that is also not very pretty is that this returns a pair. So later on, if the to keyword here will return a tuple, so a pair of developer and this builder, which the only reason is that we need the developer at later points in time, because of course we need to, for instance, find out their the hours that they worked in a month, and this is probably the most straightforward way to do it, which I'm also not super happy about, but we can get rid of that as well later on. The next step now is one that can fail. You can see here we have a try catch, and our human resources client might throw a custom exception, which is human resources exception, which can be all sorts of things. I don't know, the connection to this external API timed out, or the developers not known to the external system, whatever. There's plenty of things that can go wrong. We just know that some stuff can go wrong. So what we simply want to do right here is we put this into a try catch, and we both get the hourly rate of this developer as well as how many hours they worked in the given period. Bear with me that this is done in two separate calls. This is just how this API works. In the example, of course, there's you might do this in one, but that doesn't really matter since it's anyways in the same try block. So if either of those throws an exception, we go in here, and what we want to do then is that firstly we want to log what happened, so yeah, that it failed, and also give the exception here into our logger, and then continue to the next mapping operation without a paycheck builder, since obviously we cannot continue if any of those failed already. So what we're going to do then is, in the case that it worked, we again return a new pair of our developer together with the builder that now has two further fields, or if anything failed, either the hourly rate or the hours worked, we return null going forward. Next step then simply is to build our builder, which might throw an exception again. For instance, if one of the fields is missing, let's say we introduce a bug here accidentally, so we also catch the exception. And of course, due to the nullability operator right here, if this would have thrown an exception already in the previous step, right here we skip this outright. So this is again just def to null, same as this one, since of course the builder is only executed if the builder is not null, which the only way that this is the case is of course if here we did not throw any exceptions. The final thing we want to do now is some actions that differ based on all the developers that we could successfully generate a paycheck for. Of course here the return is now developer and the final paycheck. And we want to do a different action for the ones that we could not generate a paycheck for. So we partition. Partitioning simply means you get back two lists with that partition your original list, in this case our paychecks, or rather our pairs of developer and paycheck, into whatever property you check right here, or predicate rather. So what we do right here is that we say we want to partition into paycheck being null or not, which obviously will give us one list with all the successful and one with all the unsuccessful paycheck generations. And the final thing simply here, which is also something that you can check out in the very first episode of Idiomatic Kotlin, is that we simply want to unwrap this whole mess with the pair and stuff, such that going forward we have our final variable right here, which is a list of paycheck and a list of developer for the ones that failed, because here obviously paycheck doesn't make sense because there is none, but we want to know, of course, for which developers it failed, such that we can persist that information. So we just destructured it right here, and we have now all of our successful and all of the failed ones. And now coming to the two actions I mentioned earlier, for each of the successful ones, we want to simply persist the entire paycheck with our repository, and then for each one log also that we generated and persisted this for developer X in period Y. For the ones that failed, we also do a for each, and we have a special method here, save failed, on the repository, which persists some sort of information to the database that within this range for this developer we could not yet generate a paycheck, such that we can retry it later, since obviously this will not filter it out in our filtering right here. Cool. Final thing quickly, we sort all the successful ones ascendingly by the developer's name, log a final thing, how many paychecks we generated in total, successfully generated, I have to say, and then we return this such that whoever calls this method gets a list of all the successful paychecks that could be generated in this method invocation. Yes, I'm not sure about you, but this is pretty damn ugly looking. Like, first of all, the code is very, very long. That's one issue. And the other one is these try catch blocks here, and this tuple that we use to move forward. And it's not the prettiest code in general. Luckily, and this of course why you're watching this video, the result type of Kotlin can help us out right here. So let's see how it would look with the result type. Alrighty, so as you can see, our main method right here looks a lot shorter. Well, it's just 4 lines. The reason, of course, being though that I put the majority of the logic into another private method. I left the original code down here commented out, such that we can maybe compare it here and there. But let's look at what changed. So what we still have is our filtering, but then the next thing that is directly different, or let's first look at what's also similar or the same, is we also sort at the end once we have our list of paycheck, and we also log the exact same thing. So essentially this line, that line, and this line are exactly the same. Only thing that changed is that now we have a map not null, which simply means that we map but only keep it if it's also not null. So it's essentially a map and then a filter, filtering out things that are null. Yeah, with this private method that I added. This still has quite some steps, but it already looks a lot cleaner, which I guess you can agree with me. And let's now check out why. And of course, it uses the result type. So we receive here today the period and the developer, and we return a nullable paycheck. Of course, reason being that with the map not null, if it is null, it is filtered out. If it's not null, we keep it and can sort it further, return it, etc. All right, of course, we start with our paycheck builder again. In this case, we can just put it right here, since this is not expected to be throwing any exceptions. And now we start with what you also saw in the episode itself, this resulted success thing. So all this is doing is it wraps our value into a successful result. There is actually also result.failure, which we have to give a throwable, of course, so exception, for instance, such that we start with a failure case. There's limited applicability to that, but there is occasionally some. And this is simply a way to have a result such that you can then use any of the methods that it offers, such as map catching. That's all the reason, because otherwise, of course, you cannot invoke these methods. The other option that you have is start with the run catching, but since this doesn't really throw any exceptions, this is a cleaner way, in my opinion. Since we know this is a successful start value, so why not use result of success to kick it off? Then the first thing we do, you can see in this case, it's two separate operations. We might as well put it in the same one though, now that I'm thinking of it, because that's also how it was in the original one. And now what happens here is pretty nice, since we, as you saw in the video, got entirely rid of the try catch. So we do exactly the same. We give the two, we use this client to get the rate and the hours worked and stuff it in here. But because of the catching part here, if this does throw an exception, any of these two calls, the exception will be caught and kept for further usage. Meaning, of course, here as well, that if we reach this with this having failed, the lambda here is just skipped. Which is nice, because then we don't have to check out anymore, do we have a null paycheck builder or not, and so on. So it's pretty nice and straightforward now. The two other things that we had in the previous example, of course, is that we had our successful and failed paychecks with this partitioning step. And here we can do it even nicer, because with on success and on failure, we can just do the same. On success, we save and log, and on failure, we also log and save it with this special save failed method. And finally, of course, we do not know at this point, do we have a paycheck or null? So with get or null, we do exactly what the method name suggests, such that we can then later map it again. Right, I think this is pretty much the example itself. You can see the code is a lot shorter. Of course, this is its own method, but even if it would be inlined right here, it would still, I would still argue that that's easier to read. Actually, I'll keep it like this, I think, because then we're comparing apples and apples, since the other one also did not use any private extra methods. One thing I still quickly want to show you, which also didn't show up in the episode, which is something that can occasionally be useful, is the .fold method that the result type offers. What this does is the following. So if we in here do fold, it takes two arguments, as you can see, on success, which is a lambda expression which receives our t, our value, in this case the paycheck, and then an on failure, which receives the exception. You might already have an idea what it's doing, but I'll quickly show you right here. So essentially, once we reach this point, the result, if it currently holds a success, will execute this, and if it holds a failure, it will execute this. The other thing, though, that's interesting is that whatever return you return out of this is what is returned by the whole fold method. So conditionally, based on success or failure, it executes either and then returns that as well. So what we can do right here is get our on success lambda expression into this spot right here, and our failure one, because of course the signature is the same, into this spot, and then also return something. So in the paycheck, in the successful one, we want to have the paycheck. In the unsuccessful case, we want to have null. And then you can see all the squiggly lines go away, because this is in the end the exact same that we had earlier with on success, on failure, dot get or null. Now we fold this into a single value, such that this is executed in a successful case, which, well, I copy pasted it, so exactly the same as on success or the on failure, and we simply then return either a paycheck or null, which of course means that, again, for map or null, we only retain the successful ones. You can here add the return at fold to make it a bit more clear what even happens here, because yeah, otherwise with just the value in the last line, it does work just fine in Kotlin, but it looks a bit funky. Right, this just as I mentioned, so if you have on success and on failure, both, you need both anyways, and you want to get the value, this is quite a nice way to fold this, essentially the 3 steps into a single one. And of course is exactly the same, that only one of the 2 will ever be executed for each of the paychecks that we iterate over right here. Cool. This was the appendix to the result of T episode of my Idiomatic Kotlin series. If you have any questions, leave them in the comments. I'll be very happy to respond to them. If you have any feedback, of course, put it there as well. And finally, I see you in the next episode of Idiomatic Kotlin. Tschüss!